Now let's get the critical path for this network. Okay, what is the critical path? The critical path of a network is the longest time path for the network. The activities on the critical path are activities that cannot be delayed. That means the slack time is 0. Okay. Now, how do we calculate the slack time? So let's say activity A, the slack time is latest start minus earliest start. So we can see that the latest start is 0, earliest start is also 0. So the slack time is 0. Okay. So is it critical? Yes. If the slack time is 0, then the activity is on the critical path. So over here we can see that if these values are the same, 2 minus 2 is 0, 4 minus 4 is 0, then this activity will be on the critical path. So you can see that this activity is A, C, E, G and H are critical activities, and the critical path will be A, C, E, G, H, like this, right? A, C, E, G, H. Okay, so the critical path is A to C to E to G to H. Now the next part of the problem is to get the probability that the project can be completed on the 15th week. As we can see that this is just an estimated time, because all these times are estimated times. Okay, so this is just estimated time, project completion time. Now before we could find the probability of the project completion time, first of all we have to get the variance of the project, okay? The project variance. Now we have A, B, C, D, E, F, G, H, and we have the variance for each activity. The only activities that we're concerned with are the critical activities. So you can see that the variance for A is 4 on 36, variance for C is 4 on 36, variance for E is 1, 36 on 36, variance for G is 64 on 36, and variance for H is 64 on 36. So to get the variance of the project, or the project variance, we have to add all the variance for the critical activities, and that is 3.11 week. Okay, so the project variance is 3.11 week. So the project standard deviation is the square root of the variance, which is 1.76 weeks. Okay, so now we can calculate the probability that the project completion time is more than 15 weeks. Okay, so we are going to use the normal Z score, or the standard normal table, to calculate the probability. So first of all, we have to convert T into Z by taking T minus 15. 15 is the mean time taken. So the project completion time that we have calculated is actually the mean time taken in the normal table, divided by sigma. So this whole thing now becomes the Z standard normal variable. And on the right side here, we follow the same method. So 15, right? This 15 is 15 here, minus 15, okay? So minus 15 divided by sigma. Now sigma is 1.76 taken from this slide, okay? And this equals to probability of Z. This becomes Z greater than 0, okay? Because 15 minus 15 is 0. And from the table, okay, we can see that from the table. Okay, let me put it here. Now, where is 0? This is 0. Okay, so the probability that Z is greater than 0 is 0.5. That means there's 50% chance that the project can be completed on the 15th week. Okay, now let's take another probability. So what happens if we extend 1 week, okay, and we want to find the probability that the project is completed within 6 weeks, 16 weeks, okay. So we want to find the probability that the project can be completed within 16 weeks. So I put a less than here because within 16 weeks, okay. Okay, so how do we calculate this? So first of all, convert to Z normal table, Z standard variable, okay. So this is equal to probability of Z less than, okay, 16 minus the mean value, which is 15. The mean value doesn't change, okay, for this project, divided by the standard deviation of the project, okay. Alright, so let me put it here. Okay, now this is equal to the probability of Z less than 0.57. Okay, let Z less than 0.57. Right. Okay, so how do we use the table to get the probability of Z less than 0.57? So let's look at this table. Okay, this table. Make it bigger. Okay. Now where is 0.57? Okay. If we look at the table, this is 0.5. 0.57 is here. Okay. So probability, this is the probability of Z greater than 0.57. Okay, this is because this is the right hand tail, the right tail table. So all these values here are actually the probability of Z greater than these numbers. This is the second decimal for this number, okay. So 0.57 is here. This is the probability of Z greater than 0.57, which is 0.2843. So let me put it here, and so we have this is equal to 0.2843. Okay, 0.2843. So the probability of Z less than greater than 0.57, probability of Z greater than 0. Let me rub this off. 0.57 equals to 0.2843. Okay, so this is taken from the table. Now, so what is the probability of Z less than 0.57? So this is going to be equal to 1 minus 0.2843, which is equal to 0.7157. Okay, so this is equal to 0.157. Okay, so if we look at this table, okay, this slide, how do we explain that? This means that there is a 71.6% probability that this project can be completed in 16 weeks or less. Alright. So what is the probability that the project can be completed in more than 16 weeks? That it will be 0.2843. Probability of the project can be completed in less than 16 weeks is equal to 0.7157. Okay, so that's it.